So, since students are yet to join, we'll start the session 5 minutes after this time. Thank you. Yes, so my voice is audible. I can see one person. So if you can see my slides and if my voice is audible, kindly you can write in the chat box or unmute and kindly confirm. Yes, am I audible? And the screen is also visible, right? So I'm assuming that you can see my screen and as well as you can hear me clear. So since some students are yet to join, the strength is quite low. We will start the session 3 to 4 minutes after. So we'll wait 3 to 4 minutes and therefore after that we can start the session. So please bear with me and give some time for the students to join. Okay. So we'll wait for 3 to 4 minutes maybe and then we can start the session. Okay. In the meanwhile, if you have some doubt, you can just ask me. Any doubts from the previous weeks or current week, or any doubt you have in mind, or any problem you are facing difficulty, we can discuss in this time. So you can unmute or write in the chat and we can have a discussion because these sessions are meant to be interactive. So if you discuss, so it will be good for you to clear your concepts. So if you have some doubt in the meantime, you can just unmute and have a discussion. So let me know if you have some doubts. So if you have some doubt, kindly feel free to unmute and discuss. Otherwise, you can wait and we'll start within 3 to 4 minutes. Okay. Yes. So any doubt? just feel free to discuss. Okay, you can unmute and just let me know if you have some doubts or you are facing some difficulty in understanding a concept. We can discuss. So I can see some chats. Okay, so insulation resistance problem in the last week we were having. I can open also. So which part of the problem you did not understand? Kindly let me know. Or what concept you are not understanding. You highlight that part because the problem was. Okay, so volume current means that when we discussed, there are two types of currents. So first you need to understand why, that how the this wire or the, I can say, underground cables which are designed are having some layers of insulation as well as some conducting region. So sometimes we need to measure the insulation resistance. Why we need to measure the insulation resistance? Because there is leakage currents, and since these are, since underground cables are of high voltage, because all the underground transmission, power transmission happens at high voltage. So, and since there the underground layers of the soil, they are also having lesser resistances. So there is possibility of leakage currents. Like there is salt water and all the soils are also having water. So there is possibility of leakage currents. Even though the insulation layer is having quite large resistance, there is possibility of leakage currents, we can tell. So that's how the surface currents also participate. It is not only the volume current, that is the power you are pushing through the cable, but also the surface current that is playing its role. So whenever you apply some test voltages and you want to measure the resistance of the insulation, then you have two types of current: the volume current and the surface current. The surface current, why is it coming? So you need to understand how the current is flowing, or the EMF, how is it applied, and for that particular applied EMF we discussed last week how the current is flowing. So like this, there is one type of current which is flowing like this from from the higher potential to the lower potential, and then there is another kind of current, also the surface current, that is very quite low, but that is also participating due to the applied EMF. So two possibilities of two types of current. So surface current you can calculate from the surface resistance. There is only one difference, that you have to take the peripheral length. The volume resistance, R equal to rho L by A. Rho means rho V, rho volume resistivity, or whatever is the resistivity that you take. But here the surface resistance, how you calculate? You calculate by the peripheral length. Peripheral length means the area wise. We also showed the dimensions where the currents are flowing. So the volume current is flowing like this, but the surface current is flowing through the, and what is the cross sectional area which you will take here? This area. This is the area perpendicular to the flow of the direction of current. So obviously current will flow from higher potential to lower potential. So you can understand this W we took and H we took. So that is the area. And to calculate the peripheral length, you can calculate this dimension. That is how the surface current is also appearing. But you keep one thing in mind, that there are two scenarios where you have the absence of guarding and presence of guarding. The presence of guarding will not allow the flow of surface currents. But if the guarding is absent, then both currents will appear. So that's why when we test without the guarding, then you can see these currents, this insulation layer also participates, and the surface current also appears. So this current is a sum of both the currents. So that's how we determine what is the surface current, and accordingly determine the surface resistance and volume resistance, or calculated the currents, individual currents. So any more doubts? So it is depending on how you apply the potential, where you apply the potential and which part of the circuit is participating. That is, you see, if the guard ring is present, then your insulation, that is your surface currents will be eliminated. You have only the volume current. But here, if you apply with the guard without the guard ring, then what will happen? Then the full area, current cross-sectional area, these peripheral lengths, all of these are participating, and for which the surface currents will play a major role. You cannot eliminate the surface current in such condition. So you need to be careful about that. What is being asked, and accordingly, once you know these informations, then calculation is not a big challenge, but you need to be careful where you are applying the voltage. Accordingly, you need to see the current direction and calculate the area perpendicular to the flow of current. That is very important. Accordingly, also you need to calculate the peripheral length, because you know how the surface currents are also flowing. So the calculation of peripheral length, the dimension, whichever dimension you need to take, and the cross-sectional area dimension, that is important. And how you will decide? You will decide that by the how the potential is applied. So that is important. Okay, so hope if you solve these kind of problems and see the lectures also and solve the problems again, then I think that will be easy for you to understand. So let us come to this week, where we have first some problem on ammeters, and then we'll drive to the problems of potentiometers and maybe some problems on energy meter, which you have in this week. So first, try this problem. Just see and give me some idea how to solve this problem, because so this will be theta. Okay. So I hope the problem is visible on the screen. Yes or no? You can see the problem. Kindly let me know. Okay. So you see this problem and let me know some hypothesis. How will you solve this problem if such problem is given to you? So any idea? Because these sessions are meant to be interactive. So you should be telling me the idea of how to do the problem. And if you can unmute or have a one-to-one discussion, it will be more useful for you. So solve with me and also discuss, and then accordingly we can proceed with the problem solving. So how can you solve this problem? First seeing the problem, first read the problem, and then tell me what is asked, and then tell me how to solve. So what steps we will follow? So this circuit given, and they are asking to calculate the magnitude of the impedance Z, this one. So obviously it is a AC circuit, which you have excited with a sinusoidal AC source. And they are asking you to calculate the magnitude of the impedance. Okay. Only the magnitude of the impedance Z, this one, where you have information of these 3 ammeter readings. Now, since it is a AC circuit, they are giving you the RMS values. Okay. RMS readings. So these all are RMS readings, right? Because this is AC, right? So your average will be 0. Purely AC sinusoidal signals, average will be 0. They are giving you the RMS values. Unless and until mentioned, consider all the values given as RMS values, not the peak values. If they are given the peak values, then you can multiply or divide by √2 to get the RMS values, but that will be mentioned. If nothing is mentioned, you have to assume that they are given as the RMS values. So these consider all these values as the magnitude of the currents and the RMS magnitude of the currents. So RMS readings, okay. So now you know that the ammeters, 3 ammeters, A1, N2 and A3, which are reading the branch currents of these circuits, their RMS value is given to you. Okay, these are already supplemented. Now, knowing this, you have to calculate the magnitude of the impedance Z. Each branch current is denoted, and you have to assume that obviously the ammeters are not having any loading effect on the circuit. That means that they are not having maybe very large resistance, because ammeters are designed to have very low resistances, and you have to assume they're ideal. That means their internal resistance is what? What is the internal resistance of an ideal ammeter, or what should be the internal resistance of an ideal ammeter? Yes, I want to hear from you. Yes. First of all, ammeters are connected in series, right? To measure the branch currents or to measure the current through which across the branch you want to measure, right? So they are connected in series. So they should ideally have zero resistance to not create any loading effect on the remaining part of the circuit. Means that they should have almost ideally zero resistance, right? Why? Because you don't want to change the magnitude of current flowing in that branch due to inclusion of the meter. Meter should have no loading effect on the remaining part of the circuit. That means their resistance should be zero. Then only they can read the true value of current flowing through that branch without creating any loading on the other part of the circuit. So assume that they are having almost zero resistance, ideal ammeters, right? Now you calculate or give me some idea how to calculate the impedance Z, the mod of the impedance Z, mod Z we want, right? So how will you do? Yes, you can unmute and just let me know.
Sir, first we have to calculate the voltage.
Okay. So calculate voltage across which branch you need to calculate? Can you name? If I name it A or B, this is, so these nodes are all same, right? So let us name them B. Then another node, or these two nodes are also equivalent, right? Because we don't have any element between these two nodes. So let us name them A again, and this let us name them C. So how will you, across what node you will calculate? Any idea? You have the RMS readings, right? So what will you do?
So by using
Yes, your voice is cracking. So can you tell me again? Yes.
by using Kirchhoff's law, we can calculate.
Yes. Using Kirchhoff's law or directly by analyzing the node also, because you know this current, right? Let us name them I2 because it is flowing through A2. So now what you can write, VAB, can you tell me what is VAB? Mod of VAB? It is nothing but mod of I2 times R. Or what is that? So mod of I2 means 3.25 times R is given as 700, right? So how much it is coming? Calculate. Yes, how much it is coming? So you have to calculate and tell me. So what is it coming? You should be ready with a calculator.
Sir, it is 2275.
Okay. Then what will you do? You know this voltage, right? Because these two are in parallel. So now I know also this current. So what is the value of Z or mod of Z? It is nothing but mod of VAB divided by mod of I1, right? If this current is I1. So what is it coming? 2275 divided by mod of I1. Mod of I1 means all calculations are in RMS, right? All in RMS. And obviously, if all calculations are in RMS, you will get the RMS value only. So 2275 divided by 5.75. What is it coming? 395.7 ohms, right? Obviously, this is the only the absolute value or the modulus, right? The magnitude of the impedance. Now, what I asked also as a sub part, that estimate the power consumed. How can you calculate power consumed? And also after calculating the wattage consumed by this impedance, power means active power they are asking, right? So this is in watts, right? Whenever they ask for power consumed in watts, you have to consider they are asking for active power, not the apparent power. So I mentioned it to be in watts. And if they are asking you to calculate the active power consumed in watts by this impedance, which is denoted as Z, and also to find the load power factor. So do you understand the difference between load and supply power factor? What is the difference? Can you unmute and tell?
No, sir.
So what is load power factor means? Power factor, what is power factor? This is the difference between the, for anything, maybe load, maybe source. This is the difference between the phase angle and cos of that, obviously. So the phase angle between those two parameters, the voltage and current parameters of that element. So if it's for the source, then you have to go for source voltage and source current, the angle between them, right? That angle. Let us name them theta S. And if it's for the load power factor, then maybe theta L, which is nothing but the angle between VL and IL. So cos of theta L will give you the load power factor, or in other words, the angle between the voltage across the load and the current through the load element or the impedance, that will give you the load power factor. However, the source power factor is completely different. It is the angle between the source voltage and the current pushed by the source or current supplied by the source. The phase difference between those two, cos of that will give you the power factor of the source. So those two are different. Hope you understand, because the current through the source and the current flowing into the load are different, and their phase angles are also different. Because some elements, maybe other branch elements, may also consume some other phase current. So the net current delivered by the source will be different compared to that of the load, and hence the theta S and theta L may not be always same. Maybe same in some critical cases, but they are apparently different parameters. So the power factor of the load and supply are different parameters. That is why you are being asked to calculate the power factor of this impedance only, not the source. So how will you do? Any idea?
So, sir, tell me again, sir.
Yes, hello. How will you do? What information can you use to calculate? So if I name this as IS, that indicates the source current, maybe you can assume the RMS value. So if this is IS, what can I write IS as? But they are obviously the phasor quantities, so I can write like this, or using small parameters for phasor quantities, because they are time varying parameters. Obviously RMS is not time varying, but considering the steady signals, but whenever you denote using phasor notations, they are rotating in space. The phasors means that in time those electrical parameters are having time variation, right? So space variation in phasor means time variation in electrical parameters, whatever the current or voltage you are denoting. So if this is IS, I can write it as sum of I2 plus I1. So how to calculate? Means that if your I2 is like this, for example, I2 is like this. Let us take it as reference. In phasor, you can take any parameter as reference, but the other parameter should be in reference to those parameters. And in phasor diagram, the criteria is all parameters within one phasor diagram should have same frequency. By same frequency, in phasor, what it means? Same speed of rotation. So in time, same frequency means same speed of rotation in phasor space. Because this space is the phasor space or phasor plane, where these parameters, these electrical parameters are having. So the time variation in electrical parameters are denoted by rotation. So this is also rotating with omega, right? Omega is the angular frequency or the angular speed. But now, what will be I1? Because we don't know what is the Z, let us assume that I1 is like this. So can you tell me how will IS look, which is the net current supplied by the source, the sum of these two, right? So this is IS. Agreed or not? Now,
Yes, sir.
now let this angle be theta. Then can you tell what is IS mod? It is nothing but I1 mod square plus I2 mod square plus what? 2 I1 I2 cos of theta whole root over. Because we know this value. This is known. This is known. This is known, given to you in the problem. But this is the unknown parameter, which is asked. So can you tell me, can you put the values? What is IS? And in the phasor, if you take RMS, all parameters are RMS. If you take peak, all parameters are peak. But the given is RMS, so we'll take RMS. So what is the RMS of IS? So IS is nothing but A3, right? Whatever the third ammeter is reading, that is only IS. Because that are reading the true values, right? Clear? So what is A3? Yes? 8.25, right? So 8.25 is nothing but I1 and I2 values are given as 5.75 and 3.25, right? Two times 5.75 and 3.25 and cos of theta. So now square both sides. So 8.25 square minus 5.75 square minus 3.25 square divided by 2 times 5.75 multiplied by 3.25, then whole root over, right? Will be cos of theta. But this is plus minus, right? But what will you take? Plus or minus? Yes. What value will you take of the?
I think minus will take because theta is clockwise.
No. Even if theta is this much anti-clockwise, or even if theta is plus, but cos of theta will be for an acute angle. If theta is acute, maybe
Yes,
plus
sir.
or
Yes.
maybe minus.
Theta is acute means we have to take positive. Okay.
Yes.
Right.
Anyway, even if it is plus or even if it is minus, I am talking about theta, the angle. But still it is acute angle. Why acute angle? Because the impedance Z will not have an angle more than 90 degree. Is it possible? No, because you have what? Either capacitive or inductive or a mixture of two, which will vary from what? Plus 90 to minus 90. So all angles will be acute angle, either plus or minus. However, the cos of that will always be plus. So for that we need to take the plus only. right? For this reason. So take the positive root and tell me what is the value of cos theta. You tell me. Calculate and tell me. Do it fast, okay? We have more problems to solve. So do the calculation. So after calculating, what are you getting? Yes. What are you getting? Yes, any answer? Sorry, this would not be root, right? You are not hearing clearly. So this root will not be there, right? If you resolve this equation, right? What will it come? It will come.
Yes, sir. Only
8 point.
only cos
Yes, yes.
theta.
But however, that was a good discussion. But that root will not participate here, right? So this is only cos theta, right? You don't need to take any further root because you squared now already both sides. So cos theta will come and then you take. So what is it coming? Cos theta? You can just simply solve this and get cos theta. So what is cos theta? Yes. So you solve. Just check whether it is coming matching. I am getting 0.65. 0.6538.
0.665.
Okay, so this is the cos of theta, means the power factor of the, but what is this theta? Power factor of the load. How you know? Because I2 and V are in line, right? VAB you can write because that is resistive, right? So the angle between VAB, since it is also the voltage across the load, this VAB is nothing but the voltage across the load. So the angle between I2 and I1 is nothing but the angle between the load voltage or the impedance voltage across the impedance and the current through the impedance. So that is nothing but the power factor angle. Okay, theta L is nothing but theta. So cos of theta is nothing but cos of theta L if you draw the phasor diagram. So that is nothing but the load power factor. Okay. So if you draw the phasor diagram and see, these voltages are all in line, right? Because whatever is the voltage across this one, same voltage is across this one. So the angle between I1 and I2, the relative angle between I1 and I2, since V2, or you can tell VAB, is in phase with I2, the angle between I1 and I2 is nothing but the angle between VAB or V load and I load. I load means I am taking I1, which is the current through the Z. So that is nothing but the load power factor angle. If you draw the phasor diagram, that will be more clear, and then you can just use these equations Simply do the vector addition and then you can get the power factor angle. But what is the power? Power consumed. It is nothing but what? Mod VL into mod IL into
I
cos.
square Z.
Yes. Yes, I square Z also you can do. But it is same as mod IL square into Z. But is it mod IL square Z or Z cos theta?
Z cos theta.
Correct.
No, sir. Huh? Why, sir? Actually, Z is only Z ही तो सर वो क्या है apparent होगा ना
Yes, but I want the active
मतलब
power.
okay.
Because in the question you see what is asked. In watts it is asked, right? So power in watt means they are asking active power, not the apparent power. Because if they ask the apparent power, then they would have mentioned the unit as kilovolt ampere or volt ampere, right? But they are asking in watts. Watt means they are asking the active power. So for active power, you need to take this cos factor. If you draw the power triangle, and then you can analyze. Okay. So RMS value of the current that will participate whole square into the active part, or the in the impedance triangle the resistive part, which is Z cos theta. So either way you can do. So if I take this one or even this one, what is IL? IL is nothing but 5.75, that square times Z. Z means the impedance, which we have calculated to be 395.7, and the cos of theta L, what is that? 0.6538. You multiply this and you will get the watts. So what is it coming? What is it coming? Around 8554 watts. Don't give in kilowatts, because in the question the power of the load is being asked in watts. So you need to give in watts only. So don't do this silly mistake. If it is asking in watts, you give in watts. If it is asking in kilowatt, you give kilowatt. If it is asking volt ampere, you give the apparent power. Then you don't need to take cos. But since it is asking watts, you can tell watts. So first read the problem. What is it asking? If it is asking only apparent power, you don't need to calculate the power factor. You would have directly multiplied V across the load and I across the load, or just IL square into Z. But it is not asking so. So hope it is clear. Any doubt in this problem? Yes, any doubt?
No, sir.
Okay.
No, sir.
So let us move to the next problem, right? So let us solve some problems on potentiometers, because this week it is important, right, for this week. So kindly read the first problem. It is an easy problem. If you have revised well, you can just see and solve this problem. It is a just a MCQ type question. Yes, so see this problem and give me the answer. So what is the correct connection? 1 or 2? What is the rule to get a balance? That the orientation of the EMFs should align. Otherwise, you will never get a null, because these voltages will keep adding up. And if voltages keep adding up, there will always be some EMF across this path, and the current will always flow. So to get a null, the potential should be aligned and oppose one another, however you understand, such that the drop also happens in this direction and the test voltage also happens in this direction, such that they align and oppose each other and get a null. So the condition to get a null, or using the potentiometer connection, you can see that these two are aligned. So which one is the correct? Yes?
सर एक बार फिर से बोलिए ना.
What I am telling, how the potentiometer, how we use the potentiometer. That is the, I can tell what that how we use the potentiometer to get the null condition. The potential drop across this path due to this source is how if this is 0 volts, if you go across this length of the resistance, the voltage increases. Agreed or not? Now this voltage at this point, between these 2 points, should match with the voltage of these 2 points of the unknown EMF or unknown source. Then only your null condition will happen. If you have a battery of 5 volts like this and you connect another 5 volts, then only no current will flow, right? However, if you connect these 5 volts with this 5 volt with some obviously resistance limited by resistance of the wire, this one, this path, this has resistance, right? So this R also comes. However, the current will always flow in this condition, right? I not equal to 0 in any condition, but here I is 0, right? So the EMF should be aligned. That is what I am telling. So this EMF and this EMFs are aligned. That is why you can get a null, and that is what is desired in this potentiometer connection. So which connection is correct? The one which is aligned, right?
First one.
First one. So you get the first one correct, right? Then see the next question. Read the question.
सर 1 mm का वोल्टेज क्या होगा यही निकालना पड़ेगा, राइट सर? Resolution means?
Yes. What is the least voltage that you can proceed with? Because you are trying to measure one voltage of an unknown source with some least count. What is the limitation or what is the resolution of that least count? Means that it is limited by the 1 millimeter. Because beyond that you cannot have the calibration of the length. And if you cannot read the length beyond 1 millimeter precision, that means your limitation of voltage measurement is also due to that 1 millimeter resolution. So what is that delta V? Is the question, or step size due to this 1 millimeter scale, because beyond 1 millimeter or below 1 millimeter you cannot calibrate using this scale, right? Because the scale itself has a least count of 1 millimeter. That is only the step size. So what will it impact the voltage step size? That is what is asking the question. So simple problem. You have the potentiometer like this to the resistance test bed or the wire, and then you have another test source. So this will be like this, aligned in the same with some meter, and then you have the jockey. So what am I interested in? This is V, this is Ex, I can write. And the length of the potentiometer wire is 10 meter, right? These all information are given. You don't have to draw all the time, but for the beginning purpose, you can just draw. The voltage across the potentiometer wire is given to be 2 volts. So what you can tell? Yes? How to calculate? Yes, what is the delta V? Yes, hello? Yes, so what is the per unit voltage? So how can I write this? 2 volt. Sorry, this is 2 volt, right? So this is EX, right? Because it is given total voltage across the potentiometer wire. That means this voltage from here to here, these 2 volts. So what I can write? Delta V as 2 volt divided by total length of the wire, which is 10 meter, and that is multiplied with what is the least length you can measure?
1 mm.
So this is per meter. For 1 meter, you have this much voltage drop. But I need for what? How much meter? 1 millimeter. So 10 to the power minus 3 meter. So delta V is 2 into 10 to the power minus 4 volts. Because for 1 meter, if you have 2 by 10 voltage drop, but I can measure 1 millimeter. So 2 by 10 into 1 millimeter. That means 10 to the power minus 3 meters. So this much is the least voltage resolution that you can proceed with the step of the voltage increment you can do in this. This is the minimum step increment because the minimum length you can measure is 1 millimeter. So you can write this as 0.0002 volts because the answer is asked in volts. Please be careful. So you have to answer correctly as per the decimal places in volts. So this is the answer. 0.0002 volts. Clear or not? Yes, hello.
Yes, sir.
So let us proceed to the next problem, right? You answer this. Yes, what will be the answer?
Sir, less than 0.8 volt.
Okay, so let me draw, okay? So this is the battery, right? It has some internal resistance. Then you have the source and the potentiometer wire. Normal arrangement, right? And then you have connected one end of the arrangement with this. Then you have the meter. And then maybe jockey is here. Now you have determined this unknown EMF EX as 0.8 volts. That is what is the problem telling you, right? And this is the R internal. So EX I can write like E battery, right? Which you are trying to measure. This is yet unknown. Now you got the balance condition at EX equal to 0.8 volt. That is what is the question telling. Now it is asking you what is the actual EMF. Because what you are measuring here is what? This voltage, right? Or this voltage. That includes both the EX and R internal. Right? If we apply the KVL loop. So balance is happening here means this voltage is 0.8 volt. So what is EX at balance condition? Please be careful. At balance condition, if a battery like this having some internal resistance is having some voltage 0.8 volts, then what is the voltage of the battery? Yes. What is the current at balance condition? Yes, at balance condition, what is the current?
Current is 0.
Okay.
Sir, right?
So if current is 0, what is the drop across this resistance?
That will be 0.
So what are these two voltages? The voltage across this total branch is same as the voltage across this battery, irrespective of the internal resistance of the battery. So if you are getting a balanced condition, that means that voltage, whatever voltage you are calculating, let's say by E, if this is E, then divided by total length multiplied by, I can write total length as capital L, multiplied by, let's say, this small l, whatever is the E bat or Ex you got, that is including the, that is irrespective of the effect of internal resistance, because the drop across the internal resistance at balanced condition is 0. So whatever large or however small that internal resistance be, that does not take into consideration, or that cannot be, that need not be considered, because you will ultimately get the true voltage, true EMF of the battery at balance condition, because the current is 0. You don't need to worry about the R internal or the drop across the R internal. So whatever voltage you are getting here, that is only the EMF of the cell. So what is the actual EMF if you are having the balance at 0.8 volt?
0.8 volt, right, sir?
Same 0.8, right? Because the current is 0. So this drop is 0, independent of R internal, right? So what is the correct option? B, right? 0.8 volt. So just see the next question. So this is the arrangement, right? Where you have a driving source and a potentiometer wire, and then you have the battery or the test source whose voltage you want to measure. That is still unknown, and it has some internal resistance. Let's say R test, and the voltage is RE test, and the current flowing is I test, and the meter is having this different positions, and you want to measure the null position in terms of the wire resistance. So first part you just read and then answer how to solve. Yes, any idea? You can kindly unmute and discuss how to solve. Because I will not be always solving. You
No,
need to
sir.
solve
Okay.
and give me the answer, right? So how will you solve? No, first discuss what is the philosophy, how will you do this problem if it is given to you. So how will you solve? What are the data that are given, and how will you proceed with those data to get to the solution? So what is the method you are going to use to solve? Can you discuss or comment about it? Yes, what will you do? Yes, hello. Am I audible? Is the question clear to you? First read the question and tell me how to solve. So these are the data that are given, that the resistance of the potentiometer wire AB, the net resistance is 20 ohm and this supply voltage is 4.6 volts. And this test EMF is given to you as 1.38 volts and the R test is 11 ohm. So how to calculate null position? That is what is asked in the first problem. Obviously null position not in terms of length but in terms of resistance. So how will you do? How will you calculate the null length? And they not only can calculate the null resistance, right? Or the position at which the jockey is connected, that resistance. Or obviously the null condition. So how to calculate that position? That position of balance, EMF balance, right? What I mean by null means current through meter G is 0, right? So current through meter G is 0 means that the potentiometer or the potential difference are same, right? Yes or no?
Yes, sir.
So how to calculate? Yes, I want to hear an answer from you. Because all the data are given, right? You only need to apply the balance equation or the potential balance condition or null. So how can I do the potential balance condition? If R at R is or at if at R resistance, that is a function of the position or the length, your balance is occurring, then how you can translate that into the balance equation? Yes, I can write what? Can you tell me this resistance? How can I find the potential drop as a function of resistance? E supply divided by total length, total resistance. What will it give me? The current through the this wire, right? And if you multiply that with R, then only you can get the voltage drop. So that voltage drop is equal to this E test. Because at balance, the current I test is 0. So since I test is 0 at balance, then what will happen? The voltage drop across R test will be 0. Just we discussed in the previous problem. If voltage drop across R test is 0 at the balance, then the voltage across this branch is independent of the value of R test. Just like the problem we discussed previously. So what is the voltage drop across this branch, net branch, which is loading this part of the potentiometer wire? It is nothing but E test, right? So how to calculate R? This resistance at which the balance is occurring. R is nothing but what? E test into 20 divided by E supply. So can you calculate R for me in ohms? What is coming? So remember that current through meter at null position is 0. Always. This equation is a condition that you need to apply. That is what we are using. We are equating this voltage with E test because we know that the voltage drop across the R test at balance condition is 0 since current is 0. So now you know this condition, and from this condition we can derive the value of R or L, whatever we need. So R is like this. You can equate and calculate. And what is L?
Sir, coming 0.6.
Yes, around 0.6. Now what is L? If you know R, what is L? So you know that if this net resistance is capital R and this net length is capital L, then small r by small l or are same. So length is nothing but what? Small r by capital R into capital L, right? So if they ask you to calculate length instead of this resistance, then also you will be able to calculate the length. So calculate the R and L both for me. So if this is L obviously in meters and R in ohms. You calculate and let me know what is L coming. This is ohms, right? So what you told R is 0.6. No, 0.6 is the wrong answer. Calculate again. This you apply E test into 20 divided by E supply. You do both calculation and tell me, because capital R you know, right? Capital R is net resistance of the wire, 20 ohm. Small r is known. Small r is what you will calculate. And capital L is how much? Capital L means net length of the wire. What is net length of the wire? It is given, right? Or you assume it to be 10 meters. I am giving you net length as 10 meters. So net length is also known. Now calculate. What is R coming? Small r, the balance position resistance up to that. Yes, how much? Hello, am I audible? Yes, am I audible? Hello. You can just calculate, na? E test and E supply you know into 20. What is R coming? You are not doing with me. E test into 20 divided by E supply. What is it coming? Yes, you are not audible. Either you can type in the chat or you can just unmute and tell me. Or you need once again, I should explain. Do you need me to explain once again?
Yes, sir. Tell me, sir.
Yes, so what I am telling is that you have the net length of the wire and you have some supply voltage. Now, when will the balance happen? When this part of the, wherever is the jockey, up to this the voltage and this voltage, these two voltages, right? One the upper one the lower one. These two voltage, when they are same, then the current through the meter will be 0. That is known as the null position, because at that condition only you can measure the EMF of the unknown source. Up to that is clear?
Okay.
So then how to calculate the upper, this part of the network or the wire, the drop across the wire, I can tell voltage, this voltage. So that is nothing but E supply divided by AB into your R, because R is proportional to length and your EMF drop increases linearly or proportionally across the length, because this is 0 volt, this is 20 volt, and as you progress across the length of the wire, potentiometer wire, your EMF drop keeps on increasing. This much also clear. So if your resistance is R, then what is the voltage drop up to this R? I can write V as a function of R. So we know E by 20 is the current and multiplied by the up to this the resistance. So this will give up to this the voltage drop. So this voltage drop at balance will be equal to the E test, because we know the current at balance to this loop will be 0. Since the voltage are same, and hence since the current is 0, the drop across R test will also be 0. Voltage drop I am telling. So then that will give you the balance voltage. That voltage will give you the E test value. So you equate this E and E test, all you know, na? E supply and E test, and you don't know this R. So that R will come out. So R is E test by E supply multiplied by 20. So that is what we have written here. So R value is coming out what? If you write R is E test by E supply multiplied by 20 ohms. 20 ohms is nothing but RAB. That is net resistance of the potentiometer wire. As you can see, that is happening linearly, right? Because voltage drop is linear. That's why your length increment and the function resistance as a function of length is also linear. That means your resistance can be found out as a linear correlation of the voltages. So what is your R? E test is 1.38, na? How much is E test? 1.38 divided by 4.6 multiplied by 20. So that much ohm. So what is R coming? 1.38 divided by 4.6 multiplied by 20. So that is coming out 6 ohm. Now you calculate length. So that will happen as a linear of resistance. So how much is L? 6 by R is 20. That is the net resistance of the wire, and small r multiplied by net length. Net length I gave you as 10 meter. So this is net length. So what is L coming? 60 by 20, which is 3 meters, right? So at 3 meter the balance is happening, and the position at which balance is happening, the resistance across it is 6 ohm. So you can be asked to calculate either the resistance of that portion of the wire at which the null position is happening, or the length across which, starting from this length, if this is 0 position, then what is this length at which the balance is happening? That length may also be asked, provided the total length of the wire is given to you. So any way type, any variant can come. Okay. So this much is clear, or I need to explain you?
No, sir. This is.
So you can be asked either the resistance or the length, but the principle is same, that the voltage drop is happening linearly across the length of the wire, length of the potentiometer wire, and whatever position is the voltage, that voltage drop is equal to the test voltage drop, and the current is 0 obviously. Then you have the true EMF of the unknown source, and obviously at that condition the current through the meter will be 0. That is what you term as the null position. So that condition we'll only use to make the balance equation, and once you have the balance equation, you can calculate the resistance and length, provided you have the total resistance of the potentiometer wire and its total length, and you can calculate R and small l. That is the resistance and length of the balance position wire. So after you know this and you have calculated the R at balance, now you are given this task, that if I move the jockey rightward, by 1 ohm by a position which has additional impact of 1 ohm in this resistance. So now if the balance was happening at R ohm position, I am at R plus 1 ohm position at the right, because the jockey is moved to the right, slided to the right, you can tell, by 1 ohm position. Now in this condition we will not have null position because there is not balanced condition. This is not a balanced condition. Then current will flow within this loop, obviously, because if this voltage drop and this test EMF is not balanced, then the current will exist in this loop. And we are being asked to calculate that current. Let us name that I test. How will you solve this? Kindly read the problem and think and tell me.
So R is given on.
R you have already calculated in the previous problem. Na? R is the resistance of where at balance, right? Whichever position you had the null condition, that condition you know, right? And you have calculated R as 6 ohms for balance. Now you are shifting the slider by a position contributing to another additional 1 ohm of the wire. So at that condition, there will be not a null condition, it will be not a balanced condition, right? Then what is the current flowing? You have to calculate that. Obviously, R is known by balanced condition. We have already calculated in the previous problem. Yes. Yes, tell me.
Sir, E test is equal to, then E test equal to.
Yes, E test equal to.
Sir, I test.
Yes.
I test across R plus 1.
Okay.
Plus I test into R test. R test also given.
No, R test is already given, na? Previous problem you see, R test is given as 11. This is what you are trying to tell me, right? So you can tell in other way that the potential drop let us tell VR. So what is the polarity of the drop? Minus plus, right? This is the voltage drop. So VR, and then you have minus E test. If you apply the KVL, and then you have this side drop, so this side will be I test into R test equal to 0. This is what you are telling, right?
Yes, sir.
Okay. But tell me one thing. Is the current in this part listen carefully, okay? Is the current through this part of the wire, the current through this part of the wire, because this is a wire, right? And the current through this part of the wire, are they same or different?
That will be different, I think. So, because this is not in null position.
Correct. So can you write this? Obviously you can write this, but you need to be careful that this current, three currents are different, right? Because it is not a balanced condition. What was the case when it was a balanced condition? This current would have been 0. This current, right? But still this current would have been non-zero, right? Because simply this is Ohm's law, right? Yeah, we have a voltage and a resistance. So current will have flown through this part, right? Current is flowing through this part still at balance. But at balance, current is not flowing through this meter. That is what I am telling. But at unbalance, current is flowing both through this part as well as through meter. However, they are different values because you have a juncture here, right? And let us assume that current is I test and this voltage drop is VR. So what is the voltage drop at VR plus 1? That should always be greater than VR because you are increasing from 0 to E supply, right? Throughout the length of the potentiometer wire. And now you are at R plus 1 resistance. So at R plus 1, your will be E supply divided by total resistance, that is the current. So what is the total resistance? RAB multiplied by R plus 1. Now you are using the voltage division rule, right? But this calculation would have been correct if this current was 0, this lower path. Agreed or not? Your voltage division would have worked if this loop was not there. Then you could have simply written E supply divided by your total resistance, which would have been the current through this wire, multiplied by this small resistance, which is giving you the voltage drop across this part. But you have another branch, na, which you need to consider. And this lower branch will load the upper branch. And you will not get VR plus 1 directly. So what is the easy solution? So this is not correct, right? So what to do? Because you have current flowing through this part also, you cannot apply the voltage division rule to calculate VR plus 1. So how to calculate VR plus 1? Yes. So you have a scenario like this, where you have a potentiometer wire and you have this R test and E test and meter, and this is E supply and this is points AB. But you need to calculate the voltage across these two nodes. What will you do? What is the easiest technique? You do the what? Any idea? You need to find this, maybe name this position C. Okay. How do you find VAC? So voltage division does not work, right? Why? Since IG, this is IG, right? Not equal to 0. If IG was equal to 0, then this lower loop would have been disabled, right? No current would have flown. This IG would have flown, would not have flown if it was a balanced condition. But now it is not a balanced condition because your position at R plus 1 ohm. So this IG also is there. So how to find VAC? At unbalance? You use the technique of Thevenin equivalent. Across what? Across which 2 points? A and C. Now to how to find? Yes, what? Can you repeat? Hello? Yes, can you repeat? If you have doubt, you can kindly repeat. That is the easiest solution to determine the voltage drop across these two nodes when you have two participating circuits, this upper one and lower one, because both are bearing different currents. So voltage division will not work here simply. So you need to find the Thevenin equivalent across A and C ports. Once you have the Thevenin equivalent model, where this lower loop is acting as the load, then you can determine the voltage. That is the Thevenin voltage. So what is the voltage across A and C? How to determine Thevenin voltage? What is the first step? Step 1. Open the load. So what is acting as the load? The lower one. So what is driving it? E supply. Agreed or not? Yes, hello?
Yes, sir.
So how can you find out the Thevenin model? That is what is the question. Any idea? You know how you have solved, I think in class or the first semester also you must have solved, right? So can you tell me how to solve the model, Thevenin model? How to derive V Thevenin and Z Thevenin or R Thevenin, whatever you know. What is the step? What are the steps to solve the
सर
Thevenin?
पहले
हाँ
सर पहले
yes.
लोड जो है लोड को निकालना पड़ेगा, उसके
Correct.
बाद
Open
सर
circuit
थेवेनिन
निकालना पड़ेगा. हाँ. Then what you do?
उसके बाद सर थेवेनिन वोल्टेज निकालना पड़ेगा.
Correct. Across
AC.
Correct. तो ये सब हम इतना मेहनत क्यों कर रहे हैं? क्योंकि we don't have the simple loop to apply the voltage division rule. We have two loops. That is why we are taking the Thevenin equivalent model. This would not have been a problem if it was null condition, because the lower loop would have been disabled. By disabled, I mean the current would have been 0. So simply we could have considered as open circuit, and we have simply applied the Thevenin equivalent. The voltage division rule. But here the VR plus 1 is not actually the VSC, right? In loaded condition, that is not null condition. So to determine VAC at the load open, so VAC at no load, this is called the Thevenin equivalent. So this is V Thevenin, right? This is not same as VAC. This is VAC at no load. That means disabling the lower loop. This is what is the method to calculate the Thevenin voltage. So what is the Thevenin voltage? Can anyone tell me? Simple, right? E supply divided by 20 ohm, that is the net resistance, into R plus 1, because you moved the slider at the right side. So R plus 1. Now what you do is V Thevenin. How to calculate Z Thevenin? Can you tell me? By load is open. Agreed. Then what you do? You find the ideal voltage source and short it. And open ideal current source. These are to find R Thevenin across AC, across the node AC, right? So you need to see across these two nodes by opening the load what is the equivalent resistance. So you have this AC and the wire, a part of the wire of R plus 1 resistance, and then you have the remaining part of the wire, and you short this battery, and you have this wire. So the remaining part of the wire you have here, and this contact you can neglect, this resistance. So what is the equivalent resistance? If I can see across these two nodes, what is the equivalent resistance? If I see from here, what is the equivalent resistance? Can anyone tell me? Net length was 20. This was up to this was R plus 1. So this must be 20 minus R plus 1. नेट वायर का 20 ओम था, 20 ओम, आपने R plus 1 निकाल दिया, तो रिमेनिंग पार्ट ऑफ द पोटेंशियोमीटर वायर रेजिस्टेंस कितना होगा? 20 minus R plus 1. तो ये दोनों पैरेलल में आ रहा है, तो आर ए सी और जेड थेवेनिन और आर थेवेनिन यू कैन राइट बिकॉज हियर नथिंग इज reactive. So R Thevenin is nothing but R plus 1 in parallel with 20 minus R plus 1. ये दोनों का पैरेलल कॉम्बिनेशन हो रहा है. तो इसका मॉडल कैसे बनेगा? हाउ टू क्रिएट? दिस इज V Thevenin in series with R Thevenin and then you connect the load. What is the load? Load is the R test and then you have the meter and then you have the E test, right? Now you can find the test current. Correct? Because this is the point where you connect the load. This current I am talking about, the meter current, test current.
सर RThevenin कैसे दिया आप एक बार बोलिए ना.
हाँ, R Thevenin कैसे करते हैं? You see the equivalent resistance across these two nodes, A and C. तो उस दो नोड के बीच में कौन कौन बैठा है? R plus 1 का एक रेजिस्टेंस बैठा है और 20 मीटर का वायर है जिसमें से 20 ओम का वायर है नेट, उसमें से R plus 1 ओम निकाल दीजिए तो रिमेनिंग कितना ओम हो गया? 20 माइनस R plus 1. 20 ओम का वायर है, R plus 1 आपने निकाल दिया तो 20 माइनस R plus 1, ठीक है. This is coming in series, in parallel with AC because the ideal voltage source need to be shorted and the ideal current source need to be open circuited. So once we short it, the voltage sources, because the internal resistance of the ideal voltage source is what? R internal ideal V is 0, right? That's why we short to find the equivalent resistance or the Thevenin resistance. Then these two are coming in parallel. If you see point C, and then point A, both are in parallel. R plus 1 and 20 minus R plus 1. So these two are in parallel. So you can calculate what is I test. How can I write I test? From this model, it is nothing but V Thevenin minus E test divided by R Thevenin plus R test. So now you need to determine or give me the value of V Thevenin and R Thevenin. So calculate. आप calculate कीजिए V Thevenin और R Thevenin का value. R Thevenin इधर से मिल जाएगा, R 6 ओम है और E सप्लाई है आपका 4.6 volts. R 6 ohm है and this is 20 ohm. So calculate what is V Thevenin and R Thevenin coming. Calculate quickly. We have two more problems to solve.
सर RThevenin आ रहा है 4.55.
Okay. And V Thevenin, you tell me. Correct. R Thevenin is correct. V Thevenin आप बताइए यहाँ से 4.6 volt divided by 20 ohm into 6 ohm. What is it coming? What is V Thevenin coming?
Sir 1.61.
Okay. So E test is given as 1.38 volts, right? तो आप इधर वैल्यू पुट कीजिए और आई टेस्ट निकालिए. आई टेस्ट कितना आ रहा है यहाँ से? ई टेस्ट आपको पता है ना, ई टेस्ट कितना है बैटरी का, जो अननोन बैटरी था उसका वोल्टेज ऑलरेडी दिया हुआ है 1.38। तो इधर प्लग इन कीजिए वैल्यूज एंड यू टेल मी व्हाट इज द वैल्यू। आर टेस्ट इज 11, राइट, 11 ohms। आर थेवेनिन आपको पता है 4.55 ohm। ई टेस्ट आपको पता है 1.38 वोल्ट। वी थेवेनिन आपको पता है 1.61 वोल्ट। What is the value of the eye test? Kindly let me know. Do it quickly. We have 2 more problems to solve. So what is eye test? Simple na, you do na 1.61 minus 1.38 divided by 11 plus R Thevenin. R Thevenin is 4.55. What is the value?
Sir, 0.0147.
Yes.
Sir, 0.01479.
Okay, you see one thing. 0.01479, correct. So this is 14.79 milliampere. But you did not consider one thing. When I wrote this equation, V Thevenin minus E Thevenin by R Thevenin plus R test, what would have been? See the current direction given in the problem. I test is going out of E test. Means that E test minus V Thevenin होगा, क्योंकि आपने जो I test का डायरेक्शन यहाँ से निकाला, ये जो हमने दिखाया इस सर्किट में, it is going into E test, right? But however, in the actual problem, it was going out of E test. So answer with proper sign. You need to consider the correct orientation or direction of I test. If this is given in this direction, then you need to calculate in this direction only. So in this problem, if you would have taken this direction, this would have been wrong, because in the question it is given in this direction. So what you need to do in this direction current? So I test needs to be taken how? Like this. So going out of E test means that E test minus V Thevenin divided by R Thevenin plus R test, and whatever plus or minus it comes, you have to answer in that terms only, because the direction given in the problem needs to be assumed as the true direction. So answer will come reverse, right? So what will it come? It will come negative, right? Just one negative sign will come. Hope you understand, right? So in the problem you need to see which direction is IG. So that direction you need to consider, okay? So in the next problem, similarly, you have moved to the left, and we already know, but current direction is still out of the E test. So you see the Thevenin model. So this is V Thevenin, and then you have R Thevenin, and then you have R test, and then you have E test. But now the current is always out of E test, positive lead, right? So here also current will be out of positive lead like this. So what is IG? If I term IG like this, so according to the convention, sign convention, E test minus V Thevenin divided by R Thevenin plus R test. Now what is the value of R Thevenin and V Thevenin? We have already seen. V Thevenin is E supply into R minus 1 this time, right? Because the resistance is now, this was R, up to this it was R. So इधर आपने 1 ohm shift किया left में, so this would have been R minus 1, right? So R minus 1 resistance, correct? Voltage division, simple voltage division divided by R. And R Thevenin is nothing but this new position. So A and J2 junction, and then you have remaining part as 20 minus R minus 1, and up to this you have R minus 1 ohm. So you have these two as parallel, because this resistance and again this resistance are coming in parallel. So if you see the Thevenin equivalent across these two ports A and J2, so R Thevenin, if you see across this, it would come out to be what? R minus 1 new resistance, that is R minus 1 parallel with 20 minus R minus 1. This is a bracket here, so kindly note this. So let me know now what is R Thevenin, V Thevenin. You need to again calculate and put these two values here, and then let me know IG. So calculate and let me know. R is 20 ohm, okay? This one, net resistance of the wire, R is 20 ohm. E test is given as 1.38 volts and R test is given as 11 ohms. So you can plug in these values and put in this equation, and after calculating R Thevenin, V Thevenin, you can calculate IG. So calculate what is IG coming. IG or I test you can tell. Yes, tell me. Yes, what is coming, you tell me. Simple calculation, right? All the formulas are in front of you. You just need to plug in the values and then calculate. So if you calculate, your R Thevenin will come out to be 3.75 ohms and your V Thevenin will come out to be 1.15 volts. If you plug in these values into this equation with R Thevenin, R test and E test and V Thevenin, then your I test or IG with sign convention enabled will come out to be 15.59 milliampere. So you try this problem. We have to jump to the other problems also. You try this problem and see this problem. This is an easy problem, right? Try this problem. You took the previous problem, right? Previous problem answers you can try in home later. You try this problem now. So what will be this voltage? I can write V secondary. This is the voltage which is applied here, right? If this voltage and the potentiometer voltage up to this point are same, then you get the balance condition and the meter deflection will be 0 or null deflection will be attained. Then how can I calculate this V secondary of this transformer? It is nothing but what? M. Yes, I want to hear from you. How to calculate?
M di by dt.
Di what I? This Y, right? Other branch current. This is nothing but V secondary, right? Agreed or not?
Yes, sir.
If you take the modulus, what you will get? M j omega, right? This is j omega, right? S. So j times omega, but j will go out. So m omega I2. Agreed? I2 is the RMS value. Because I2, if you derive it, what will you get? S times that I2 in Laplace, and S means j omega. Again, you go back and in time you get j omega. So j you go out, and then you get the m omega I2 as the magnitude. So m omega I2 means you can write 2 pi f m I2. I2 is this current, right? So this is the secondary voltage. And this voltage should be in phase with this first potentiometer voltage. So 2 pi f I2 into m, this is the balance condition. If we try, then what will be this? This should be this I1. If I assume this is I1, okay, multiplied by the net resistance of this wire, or net length I can tell, because resistance and length are proportional, divided by this much length. Let's say this I term as net length, and this I term as maybe small l. So net length capital L I can write. Because these are only resistances, but resistance and lengths are proportional. So I can write in terms of length also. So I times R is the net voltage drop, and then I get the voltage drop for L. Any doubt? So I need to multiply it with the net resistance, right? Because net resistance R is known, right? So what will be the R is 50 ohm, right? Net resistance of this potentiometer wire, first potentiometer wire. So if this current is I1, then I1 times R is the voltage drop, you can tell. And this voltage drop is happening linearly across the length. So the portion of the length I will have to take. So there I did a mistake. This will be small length by capital length, right? I1 times small l by capital L. Small l is this much, capital L is this much. So this is R ohm, and the length is L, is the length total. Okay. So if you see how I do, this current times the resistance is the voltage drop, total voltage drop across the length of the resistance. And then I have to multiply it with, to get the voltage drop across the small part. So I have to apply unitary method, right? This is the net voltage drop across how much length? Net length. And for this much length, we have to apply small l. So I1 into capital R, that is the net resistance, into small l by capital L will give you the voltage drop across that small part. And that is have to be same as this secondary voltage to get the balance condition. So I equate these two equations. Now can anyone tell me what will be the relation between I1 and I2?
Connected
Yes.
in parallel, na?
What is connected in parallel?
Both the potentiometers, the transformers.
Potentiometers are separate. Only potentiometers are energized by transformer arrangements to create phase shift of 90 degree using this R and C. So what is happening? You have the AC voltage, one source only, one energizing source, and you have a transformer here. So it is tapping the actual voltage and converting it to the supply, energize this potentiometer. So one AC potentiometer you have energized with the normal AC supply voltage. Now to create a phase shift of 90 degree, however keeping the amplitude to be same, other parts are all same, similar to this potentiometer. These two potentiometers are sitting separately, not connected in any manner. But to create an energizing voltage of 90 degree difference, phase difference, you need to energize this to the second transformer. All turns are everything are same, but only the phase shift you need to attain using this variable RC phase shifting, you can tell, arrangement, and with appropriate number of turns such that energizing parameters are all same and other potentiometer parameters are also same. Only the energizing voltage is in quadrature. However, you know, to get a balance, the voltage drop across this should be in phase. I can tell, to get a balance or null condition, the voltage should be this V secondary, you can see, should be in phase to that of the primary potentiometer. So accordingly, the balance needs to take place. So that's why we apply this balance equation, and we are comparing this voltage and through obviously this current, and we are calculating the amplitude of the voltage with that of this potentiometer voltage, the drop across this much length. And this is the value which they are asking you to calculate, this length. Now you know, since this is di to dt, obviously we will have a phase shift of 90 degree, because you know j, if we multiply the phasor by j, then it rotates by anti-clockwise by 90 degree. So obviously this voltage will be shifted 90 degree. That is for sure. That's why quadrature potentiometer it is given. But in phase with the, since this voltage, originally the voltage, energizing voltage was 90 degree shifted compared to this primary voltage, and again you have a 90 degree shift. That's why, that means these two voltages are in phase, because the main voltage and this voltage was 90 degree shifted by this phase shifting arrangement. Again you have a 90 degree shift due to this di to dt. Okay, due to this AC current, the voltage is again 90 degree shifted. So that means these two voltages are in phase. That is clear. Now we are equating the amplitude or the RMS value, you can tell, of the two voltages. So how to calculate? One is by simple potentiometer unitary method, division, voltage division. I into L or I1 into R is the net voltage drop, and you scale it as per the length, the small length by capital length, to get the voltage drop across this much portion of the potentiometer, and that needs to be equated to V secondary. V secondary we already calculated, omega n into I2. That is I into X also, you can say. I into X mutual, you can tell. So now if you calculate, what you get, you just calculate I1 and I2 are same, right? How we can say I1 and I2 are same? Because this energizing voltage amplitude and this arrangement are all similar, right? All same. Agreed? So I1 and I2 are same. Because if you model the transformer, the shunt path is having the M. However, there is no other parameter in the series path. That means your I1 and I2 are same, because other part of that potentiometer is similar to that of P1. So I1 and I2 are same. You can calculate. I1 and I2 you can eliminate, and then you can calculate small l. This is what we need. So small l can we write 2 pi f m multiplied by capital L divided by R. So you calculate, what is it coming? R is 50, right? What is coming? F is 60, right? So 120 pi times m. M is 102 into 10 to the power minus 3. And then you have the length, net length. Net length is given as 12 meters. So you multiply with 12 and then you divide by 50. So this is the value of L. So calculate, what is it coming? This expression you calculate. It will give you the answer in meter. But the answer is asked in centimeter. So you tell me in centimeter, what is it coming? Yes, in centimeter, what is coming? So L is, if you solve, L will come out as 928 into 10 to the power minus 3 meter. Means 922.8 centimeter, right? Agreed? Okay, so you try this problem and you solve this one problem is on energy meter. Yes, please. Please try this problem. It is easy, right? It is not complicated problem. Simple unitary method you need to apply. And then at the end, it is asking you to estimate the error. So simple one-line problem, 3 steps, 3 parts, and you can easily solve. So try 1 minute, and I will give you, and then we can discuss the solution, right? Yes, so solve the problem, the measured energy, what is the voltage, current, and all those things you need to answer. That's 240 volt, right? This is RMS. Single phase RMS. And your current is 30 ampere. This is also RMS. And cos theta is 0.85. So how can you calculate the kilowatt hour? This is the units, right, for the energy meter. How to calculate? E is nothing but VI cos theta, active part, in kilowatts divided by 1000 and multiplied by number of hours. So for 2 hours they are telling. Let us do for 2 hours. And continuously we are running this load and we are recording the energy in units, that is in kilowatt hour. So kilowatt hours. So what is V? 240. I is 30. Cos theta is 0.85 because that is the power factor, and divided by 1000 obviously to convert from watt to kilowatts and multiplied by 2. This is the energy actual. Calculate what is E actual. And to make this E actual, how many revolutions the aluminum disc needs to rotate? Because you have this information
12.
also. Yes, hello.
Yeah, 12.24 is the answer.
Okay, let me check. You are answering in kilowatt hour, right?
Yeah, yes, sir. Yes, sir.
Yes, let me just calculate this, how much it will come. 240 into 330 into 0.85 into 2 divided by 1000, right? So 12.24 units or 12.24 kilowatt hour. This is the actual energy that is dissipated and recorded by the instrument. That should have been recorded by the instrument, actually, true value. And to record this true value, how many times the disk needs to spin? Because it is given that for recording 1 kilowatt hour, your disk needs to spin 150 revolutions. To record 12.24 kilowatt hour, how many times your disk needs to revolve? 150 multiplied with 12.24, right? This many revolutions. So what is it? You can kindly calculate.
1836 will come in.
1836 revolutions.
Yeah.
So if would have rotated 1836 times, then your actual energy would have been recorded. But due to some errors, it rotated 1775 times. So you need to calculate, see, a natural phenomenon will be if the energy meter revolves lower number of times, the energy recorded will be, or the energy measured will be lower than the actual energy, right? This is trivial. And you can also calculate and check. Because for 150 revolution, you have 1 kilowatt hour. If it is rotating lower than 1836, 1775 is less than 1836, right? So obviously, recorded energy is lower, right? Because for the true energy to be recorded, it would have rotated 1836 times. But it rotated 1775 times as per the problem. So the energy recorded will be lower than the actual energy dissipated. So that we can answer. And what is the error? So error is how much? 1836 minus 1775 divided by as a percentage of actual. So actual is 1836 times 100%. So calculate what is it coming? 3.32%, right? This is the error. Okay. So hope the problem is clear. And similarly, you have one more problem on the Kelvin-Verlet bridge, the decade potential divider. So it is a simple 4-stage decade potential divider. You know the arrangement, I hope. I guess you know the arrangement of the decade potential divider. Only you have been given the information of the number of stages. Each stage you have 10 resistances and they are correlated with the 1/5 times the previous. Hope you know that thing. That in every stage you have the resistances and 2 resistances of the previous stage is equivalent to 10 resistances of the next stage. If you do so, then you can have the decade division 1/10, because those 2 R and 10 will come in parallel, and then if you do, you can get the R next. If you make such arrangement in the next stage that the R next is R previous by 5, then if you connect, you will get the 1/10 of the voltage in every, I can tell in every stage, the voltage across the per resistances will be 1/10 of that of the previous. So like that, if you do your relation, you have to maintain the relation of the next resistance of the 10 resistances. Those magnitudes should be 1/5 times of the previous resistance of the previous stage, I can tell. So in every stage, this relation needs to be maintained to get the 1/10, the decade division of all the 10 resistances. To get the so this relation should be maintained, okay, to get the decade division. So now can you tell me what is the value of each resistance in the last stage of the potential divider and the, yes, it is asking the resistance. So how can you calculate? I told you per stage this is happening. Then again the next stage it is that stage divided by 5. So R by 5 to the power n minus 1 will come. And you have the first stage to be 1000. Every stage it is getting 1/5 times less. So after 4th stage it will be R by 5 cube. Because one stage is already there. R by 5 cube. R first, I can tell. R first stage by 5 cube. So R final stage. This is the 4th stage. So 3 is n is 4, n minus 1. 3 is n minus 1. So what is this coming? You calculate. Yes, you calculate. 10,000 is the first stage divided by 5 cube. How much ohms is coming? Calculate. Simple, right? 10,000 divided by 125. How much is coming? 80 ohms, right? So this is the final decade, that decade potential divider final stage. Each resistance value will be 80 ohms and there will be 10 such resistances to create the decade division. So 1/10, then 1/100, then 1/1000. Accordingly, whatever resolution you need, you plug in the pointers of every stage at that position to get the equivalent least count of the voltage, and the stage will define the number of additional decade stages. So 10th, 100th, then in fractional terms I am telling. So the resolution will increase as the number of stages will increase, and the resolution can be set by setting the pointer positions of every stages. So that is how a decade potential divider works, and the relation you need to maintain among the each stage resistances. So the final stage resistances is related like this, maintaining this relation, and to get the decade relation, and you get the final resistance as 80 ohms. Okay, any doubt?
No, sir. No, sir.
If you have some doubt, you can let me know. Okay, so these are basically the problems that can be solved, and if you solve this, you can get your concepts also clarified. You can just solve these kind of problems, or also to check that how the least count can be changed by changing the tapping position. That has already been done in the class also. You can just revisit and just see how the changing the pointer position can change the least counts also. So hope this will give you some dimensions and you can work upon it, and then you can solve more concepts, and if you have some doubt we can discuss in the next class. Okay, so this is much up to this much. I think it is clear, or if you have any doubt you can let me know. Yes, any doubt, or we can end the session.
Sir, if they're asking for a second stage or third stage, what could we do, sir?
Yes, so second stage, what we will do similar arrangement by maintaining this
Okay.
correlation. However, number of stages will be reduced in 2 or 3 stages. So number of stages reduced means the resolution will also reduce, because you go on increasing the number of stages, the more least count you get in the decimal places I am talking of the voltage measurement. So that is the only division, only difference. Otherwise, the stages, if they are giving 3 stage, then accordingly the resistance value you need to solve. If it is a 3 stage, then it would have been R first stage by 5. This 5 will be constant divided by n minus 1. So 3 minus 1. So R first stage by 5 square. So by 25 you do. So for a 3 stage, you have this much. And the least count will be also governed by the not only the number of stages. So least count of voltage in final stage you tap na, that V out where I'm talking about, that will depend on 2 things: the slider position in every stage, in each stage, and the resistance value. So to get a decade correlation, you need to maintain this value, this relation, sorry. Otherwise, you will not get the decade correlation. Hope you understand, right? So this is mandatory to be maintained. Otherwise, if it is not maintained, you will get some other values, right? Which is not 1/10 in every stages of the resistance. To make it 1/10 in every stage, we are doing this relation. So this is a decade correlation. You need to maintain this relation, right? So that 2 of the previous come in parallel with 10 of the next and get a 1/10 of that. Hope it is clear, right? So if there are no doubts, we can end the session, and thank you for listening attentively, and hope you will try more problems, and if there are some doubts, we can then discuss in the next class. Okay. So thank you.
Thank you, sir. Thank you, sir.